So good morning everyone and welcome to the lecture. This is lecture number 3 in rotation, and we are dealing with questions on pure rotation. In the last class we had seen what we had seen. We had seen that relation between pure rotation and circular motion, and we had seen all these terms such as angular displacement. We had seen what is angular displacement again. We had seen what is angular velocity, and we had also seen angular acceleration. And it is similar to circular motion that we are going to study. And then we had seen the various equations of motion between linear and angular quantities. Now we can call it rotational quantities. And we were trying to find out how we can solve question, and we had done a couple of questions. We had found out how we can find out omega angular velocity from revolutions per minute. And then I think we were discussing a question which we were trying to solve, and that is a question with which we are going to start today's class. I think this was a question, so I will give you a couple of minutes to solve this question. Question number 1. The wheel of a car is rotating at 1200 rpm. On pressing the accelerator for 10 seconds, it starts rotating at 4500 rpm. What is the angular acceleration? You will have to find out the angular acceleration, and I hope and I know that you know how to do this. Yes or no? You know how to do this? Okay, great. So I'll give you 2 minutes, solve it, and give me the answer. So how you got to do this? First of all, you have to find out the angular acceleration. How do you find the angular acceleration? Alpha. That will be equal to final angular velocity minus initial angular velocity divided by time. Yes or no? Now remember, this angular velocities are not given in radians per second, it is given in RPM. So I will convert it, and I will convert it in the same formula only. So I will just write it as 2 pi by 60, that is the conversion factor, multiplied by omega 2 is 4500, minus omega 1 is 1200. I'm just writing everything together, divided by the time is 10 seconds. 10 seconds. Yes or no?
Yes, sir.
So that will give me, I can just cancel this out. This will be 30. So this will give me pi by 300 multiplied by 3300. Yes or no? Yes or no?
Yes, sir.
So they can cancel out these two. I can cancel out this. So it becomes 11. So the answer becomes 11 pi. 11 pi radians per second square. Yes or no?
Yes, sir.
11 pi radians per second square. That will be the answer of acceleration, but it is in radians. So now I have to convert it into degrees. So how will I convert it into degrees?
Into 180. Into 180
Into 180. Pi radians is 180 degrees. So I multiply 11 pi by 11. So I'll get an answer in degrees. Well done. And the answer will come as 1980 degrees per second square. We understand this?
Yes.
So that was all. You just have to multiply, divide. There were a couple of things that you will have to remember, and nothing else. We understand this. Chalo, let us now move on to the next type of question. All these type of question, they are going to come in your exam beta, whether they might come as in rotational motion or they might come in circular motion, doesn't matter. I hope you are able to understand the gravity of the situation. This is the next question, simple one, and I would suggest, and I'll give you 2 to 3 minutes to solve this question. Now wheel is at rest, its angular velocity increases uniformly from and becomes 60 radians after 5 seconds. What is the total angular displacement? I'll give you time, 2 minutes to find out this one. Once you are done, please let me know. So how are you supposed to do this, beta? You have to find out the angular displacement. Yes or no? Now to find out the angular displacement, you can use this formula omega 1 t plus half alpha t square. Yes or no? Now this particle is at rest. So your omega 1 becomes how much?
0.
0. So you now just need to find out the value of alpha. As soon as you get the value of alpha, you can find out the value of displacement. How do you get alpha? To get the value of alpha, you can write omega 2 minus omega 1 divided by t. Yes or no? So what will be your alpha coming? Your alpha will be coming as what? Omega 2 is 60. Omega 1 is 0 divided by 5. So it will be coming as 12 radians per second square. Yes or no?
Yes, sir.
And you can find out your angular displacement. Angular displacement will be half into 12 into time is 5 square, and that is your answer. What is the answer that you are going to get? 150. We understand this?
Yes, sir.
This is one way of doing it. You could have done it in a different way though, a very shortcut way. What is the shortcut way? You could have used this equation, which I don't think we have ever used. You could have used this pink equation, and you could have got the answer from this pink equation in one step. You could have got the answer from this pink equation in one step. I'm going to give you a minute because I want you to use it on your own and understand. If you know all these equations, depending on which quantities are given to you and which quantities are not given to you, you can probably get the answer faster. That is my only concern. You have to get your answers fast. Now, if you can use this equation, sorry, and I'm giving you time, you can use this equation, you can get the answer very, very fast. In fact, you know the value of omega 1, you know the value of omega 2, you know the value of time, you can get the answer pretty fast. Are you getting the answer? The equation is right in front of you. Are you getting the answers, bacha?
Yes, sir. 150. We got it.
See, let me also do it for you once. Second method. Second method. What is the second method? So what I'm going to do, I am just going to write second method. Displacement can be written as omega 1 plus omega 2 by 2 multiplied by t. Omega 1 is 0, omega 2 is, oops, why I'm writing omega 2? It is 60 divided by 2 into 5. And you can see so nicely you are getting the answer as 150 rad per sec square. Yes or no?
Yes.
Without doing all this lamba choda thing. So if you are smart enough, you can get the answers quickly. For that, you will have to remember some things, and if you can remember those things, you can do well. Can I give you the next question?
Yes, sir.
Okay. I will give you the next question. And this is the next one, question number 3 or 4, depending on how you are seeing it. A wheel initially at rest, so initial angular velocity is 0, is rotated with a uniform acceleration. The wheel rotates through an angle theta 1 in the first second, an additional angle theta 2, remember that, additional angle theta 2 in the next second. What is the ratio of theta 1 by theta 2? I will give you 2 minutes to solve this question and get the answer. So this is how you solve it. You write the equation for the first second. You write the equation for the second. Theta 1 is the angular displacement in the first second. Then theta 1 plus theta 2 is the total angular displacement in 2 seconds. You write the equation of theta 1. You write the equation of theta 1 plus theta 2. You find the equation. You find the value of theta 1. You find the value of theta 2. And then you find the ratios. We understand this, yes or no? We understand this, everyone? Okay. Are you noting it down? Have you
Yes, sir.
noted it down? Have you noted it down?
Yes, sir.
Okay. Then comes this question. This is the next question, question number 4. As a part of maintenance inspection, the compressor of a jet engine is made to spin according to the graph as shown. What is the number of revolutions made during the test? On the left hand side, you can see is revolutions per minute. Revolution per minute is actually omega. Revolution per minute is actually omega. Do you understand this? Revolution per minute is omega. Yes or no? And here on the x-axis, I have time. So it's a graph between omega. It's a graph between omega. It's a graph between omega and time. So you have to find the number of revolutions, or number of revolutions you can say is like angular displacement. So omega t graph is given to you. From this graph, you have to find the angular displacement. That is the question, and I give you 2 minutes to solve it. Will you be able to do this? Yes or no? Do you know how to do this, or shall I do it for you? Do you know how to do this? Do you know how to do this? Okay, I will do it then. So this is a graph between omega and t. You have to find out the angular displacement, or the angle, or the revolutions that it has made. You have to find out the area of this graph. If I ask you a question, beta, please, if you don't know, at least say no, so that I can move ahead. So you have to find out the area. I waste a lot of time just asking you whether you have understood something or not. 30% or 40% of the of my class goes into asking whether you have understood or not. And you don't reply. So just reply at least, so that I don't waste my time and your time in the class. So in this graph, what you have to find out is to find out the area under this graph. Can you find out the area under this graph? Yes or no? Yes? Okay, so I'll give you 2 minutes. Find out the area under this graph. That will give you the angular displacement. 2 minutes they'll give you. So let me help you in finding out the area. How are you supposed to find it out? You can break it into triangles and rectangles. This is one triangle that I have created. What is the area of this triangle? Can you tell me? No one knows it. Okay. Half base into height. Base is 1. Height is 3000.
1500.
That, that is this red area. Then this blue area, again this is a triangle. Can you tell me the area of this triangle?
Of 1 into 30,000. 3,000.
Half into base is 2 into 3000. That is this area. Then I just need to find out this green area, which is the area of a rectangle. How much is the area of this rectangle? Length is, oh, this is not 2 point, I think I made a mistake. The base is not 2 here. It is, I think, 1.5. So I've done a mistake in calculating the base. 1.5. And this is 1 to 3.5. So this is 2.5. So 2.5 multiplied by 3000. As you can see, I could have done this in this fashion. But I could have used the area of a trapezium and done it quite fast. What is the area of a trapezium? Anyone knows? I can straight away write the area of a trapezium and find it out. Area of a trapezium is half into sum of sides, yes or no,
Yes, sir.
multiplied by the distance between the sides. So I can just write this half. I look at one side, the lower side is 5 meter long, for 5 minute long, plus the upper wala side is this length. How much is this length? This length is 2.5, 2.5, and just multiplied by the height, which is 3000. So remember, instead of getting into triangles and rectangles, it is always easier to find it from the trapezium. You just have to remember the formula of the area of the trapezium. If you just remember the formula of area of the trapezium, the rest of the things would be coming very closely. Do we understand this?
Yes, sir.
Okay. I'll give you a minute to note it down. Meanwhile, I'll prepare the next question. I hope everyone is noting it down. These are the type of question beta that are going to come in your exam. Simple ones. You just have to understand them and solve them accordingly. Can you move on to the next question, beta? Can you move on to the next question, beta? Okay. Note it down.
Okay, per minute per second. Number of revolutions.
Shall we move on to the next question?
Yes, sir.
Okay, this is the next question. The question is long to read, but it is very easy to solve. So I'll give you 2 minutes to read the question and give me the answer. The question is very simple. A bucket is being lowered into a well by a rope passing through a pulley. The radius of the pulley is 10 centimeter. The rope is not slipping on the pulley. You have to find out the angular velocity and angular acceleration of the pulley. It is given that the speed of the pulley is 20 centimeters and the acceleration of the block or the pulley is the acceleration of the bucket is 4 meter per second square. So velocity and acceleration are given to you. You have to find out the angular velocity and angular acceleration. You will have to use that relation between velocity and angular velocity, between acceleration and angular acceleration. Do you remember those results? Between velocity and angular velocity, between acceleration and angular acceleration. If you don't remember it, I'll give you time. Go back, look at those results, and then give me the answer. You have 2 minutes to solve this question. Let me know once you are done. Yes, bacha, anyone with an answer? Well, the formula that you had to use was V is equal to omega into R. So your omega becomes velocity divided by R. That was the formula that you had to use. No one remembers that formula? That is very bad. Given you the formula so many times, beta. I'm not expecting this from you. See, I had given you the formula here also. It was given in the vector form. Here you go back and just write the formula in the scalar form also. V is equal to omega R. Just write it like this also. V is equal to omega R. I thought that you know it. I told you that, but probably you missed it. V is equal to omega R and come into angular acceleration. And here write this formula. Here write this formula. Acceleration is equal to alpha R. Please write it, beta. These are the two formulas that you have to use here. These are the two formulas that you have to use here. So I can now find out the value of omega. Omega will be equal to V. V is given as 20 centimeters per second divided by 10. So this becomes 2 radian per second. Do we understand this? Well done. Then you can apply the same formula and not the same formula, similar looking formula for acceleration. The formula for acceleration is alpha into R. So from there you can find out alpha as A divided by R. Let me now put this formula here. Alpha will be equal to 4. Remember it is meter per second square. So I will have to divide it by meter. So divided by 10 centimeters in meter is 0.1. So it becomes 40 radians per second square. You will say, sir, here you have divided by 10 and here you have divided by zero point 0.1. Why is that so? Remember, this was given in meter per second. So I had to convert it into meter. This angular, this speed was given in centimeter per second and radius was also in centimeter. Therefore, I did not have to change it because centimeter and centimeter will cancel out. Do we understand this? That is the difference in the two. In one case, I had to convert it into meters. In the second case, I did not have to convert it into meters, and I got my answer that way. Now let us move on. The last question for today, and that will clear all the doubts. Have you noted this down? Great. So this is the question, and I think we have done a similar question. And now I expect you to solve this one on your own. Question number 7. The wheel of a motor accelerated uniformly from rest. So it is rotating from rest. It rotates through 2.5 radians during the first second. It rotates 2.5 radians in the first second. You have to find out the angle rotated in the next second. So does this question remind you of something that we have already done? Does this question remind you of something that we have already done? That is the hint. And these are the type of questions that are going to come. So I will give you this question as homework. Can you do this question as homework? Will you be able to do this question as homework? And I will expect the answers in the next class. Let me tell you the answer. The angle rotated in the second. Angle rotated in the second. That is the answer. That is the question. And the answer is 7.5 radian. So I am also giving you the answer so that once you get this answer, you should be able to check your answers. And this finishes our this section of questions on pure rotation, where we have used alpha and other things. We have seen that everything that we have studied in translation motion, velocity, it has a counterpart in rotation. Velocity, the counterpart is angular velocity. Acceleration, the counterpart is angular acceleration. In next class, we will come across the third term, the counterpart. Counterpart of velocity is angular velocity. Do we understand what I'm saying? Counterpart of acceleration is angular acceleration. In the next class, we will see the next counterpart. What do you mean by counterpart? Whatever job these terms we are doing in translation, the same thing the counterparts are going to do in rotation. So we will see that in the next class. Take care. God bless all of you. Bye bye. Have you understood what we have done in today's class?
Yes, sir.
Okay, then I'll see you in the next class. Take care. Bye bye,
Bye.
everyone.